Alright, so this is a notes. So, guys, pay attention. So we're now transitioning to graphing motion, using graphs to actually describe motion. We've been looking at how to use the equation to describe them. Now we're going to be looking at graphs that describe motion. So remember that motion is a change in position measured by distance and time. Speed tells you the rate at which an object moves. Velocity tells you the speed and direction of a moving object. And acceleration tells us the rate, speed, or direction changes by. So let's look at time distance graphs. So plotting distance against time can tell you a lot about motion. Let's look at the axes. Time is always measured on the x-axis, the bottom of the graph. The further to the right on the axis, the longer the time from the start. Distance is always plotted on, distance is plotted on the y-axis, the side of the graph. The higher up in the graph, the farther away from the start. So if an object is not moving, a horizontal line is shown on the distance time graph. So time is increasing to the right, but its distance is not changing. We say that object is not moving, we say that it is at rest or stopped. Note, it's very important that you look and make sure we're actually dealing with a distance time graph. That there's distance here and time here. There are multiple different graphs, and you need to label the axes. So, if an object is moving at a constant speed, it means that it has the same increase in distance over time. So if it's moving at the same speed, it's going to be a straight line. The time is increasing toward the right, and distance is increasing constantly with time. So we're constantly getting farther and farther away from the start. A constant speed is always shown by a straight line. Look at the two moving objects. Both of the lines in the graph show so that each object is moving the same distance, but the steeper dashed line got there before the other one. So a steeper line indicates a larger distance moved in a given time. In other words, it has a higher speed. Both lines are straight, so the speed will be constant. So if the line is steeper, it's meaning it's moving at a faster speed. And because they're both straight, it means that it's a constant speed. This one is just a faster speed. So this one could be like 80 miles an hour, and this one could be like 50 miles an hour. This graph that shows acceleration looks differently from those that show constant speed. The line in the graph is curving upward. This shows an increase in speed since the line is getting steeper and steeper. So right here is mostly straight, so it's going to have a small speed. And this right here is very steep, so it has a higher speed. So the steeper you are indicates how fast you're actually moving. And because it's changing steepness, this is meaning it's accelerating. So in other words, in a given time, the distance the object moves is changing, getting larger. So it's accelerating. So acceleration looks like a curve, whereas constant speed or no acceleration looks like a straight line. Make sense? So, a distance time graph tells us how far an object has moved with a given time. The steeper the graph, the faster the motion. A horizontal line means no change at all. That's the object that's rest. And a downward sloping line means the object is returning to start. So looking here at, for example, this line right here. Right here, it is moving at a steady speed forward. When it is horizontal, it means it is stationary. It's not moving. Its distance stays the same. And when it's negatively sloped, it means it's moving backward or toward the start. This line right here is curved, which means it's getting faster, so it is accelerating. And this line is constantly changing, the straight line, so it's a fast and steady speed. Make sense? So let's do some examples. Which of the graphs shows that one runner started at 10 yards further ahead of another? So which of the graphs shows that one person started 10 yards in front of the other person? A. So we're looking at the start only. We're looking only at the start. So here, they start 10 yards away. Here, they started in the same spot. Here, they started with a distance of 20 away. And here, they started at the same spot. Alright. So we look at their distance values at the start, because it says started. Make sense? By the way, let's see. Let's go to the next one. In which of the graphs below are both runners moving at the same speed? So remember, the slope of the line tells you what speed is going at. So this one is more steep. So in this one, this line is going faster than this line. In this one, this is the faster line because it's more steep. Here, these two lines are parallel. So they have the same steepness. So in here, both of these runners are moving at the same speed. By the way, what is their distance at the start? 2. They have a distance. So they start 10 yards away from each other. And they finish 10 yards away from each other. Here, they started 10 yards away. And then they eventually hit each other right here. Here, they start at the same place. This one is running faster than the other one. And he ends up beating him by 10 yards. He gets 10 yards ahead of him. And in this example, so this person starts at 10 yards and runs 10 yards, ending at 20-yard position. So he starts at 10 yards and he runs the 20 yards in 4 seconds. So looking at this line right here, this line states he began at 10 yards and made it to the 20-yard line in 4 seconds. So what would his speed be? So he went from 10 yards to 20 yards in 4 seconds. What was his total distance he traveled? He traveled a total distance. So his total distance is 10 yards. And he did this in time for 4 seconds. So he did this in 4 seconds. Remember that speed is equal to distance over time. So he did this in 10 yards per 4 seconds, which would be 2.5 yards per second. Looking at this person, he went from 0 to 30. So he went from 0 yards to 30 yards. So his distance he traveled, so he traveled a distance of 30 yards. And he also did this in 4 seconds. So his speed, he was traveling at a speed of 7.5 yards per second. And this person was 2.5 yards. So this person is clearly faster. By the way, code word of the day is beta. For those at home. So the distance time graph below represents the motion of a car. Match the descriptions with the graphs. Explain your answer. So description 1 is the car is stopped. Which graph corresponds to the car stopped? C. So 1. So the car is traveling at a constant speed. A. So he's traveling at a constant speed. The speed of the car is decreasing. So is the speed changing? If the speed of the car is decreasing, it's changing. Changing means acceleration. Acceleration is curved. So another way of thinking, so this would correspond, number 3 would correspond to this graph. So if you're slowing down, so if I were to run at you at full sprint, and then I were to try to stop, I am slowing down, but am I still going to hit you? I mean, like if I don't stop and climb, I'm still slowing down. If a car immediately starts coming at 50 miles an hour and slams on its brake, it is slowing down. The distance is getting less and less, but he's still moving forward. The car, when you slam on the brakes, are still moving forward. So this distance you're traveled, the slope is getting less and less, but the car, until it comes to a complete stop at the end, the car is still moving forward. So the speed of the car decreasing will correspond to a line like this. And then a car coming back, so moving to the back, that would correspond to this one. Because I was testing y'all, you can clearly see that I was going right at 4, seeing if y'all are going to point it out. So graph A matches 2. So graph A matches 2 because it is a straight line. Graph B corresponds to 4 because it is negatively sloped. negatively sloped line. Graph speed C corresponds to 1 because it is a flat line. Flat horizontal line. And graph D corresponds to 3 because it is curved. So, by the way, slowing down will be curved like this. If you're speeding up, so speeding up would be curved like this. So this is speeding up. You're gaining speed. And slowing down looks like this. So if you're slowing down, your speed is getting less sloped. And if you're speeding up, you're getting more sloped. Make sense? Wait until we start adding math to it. It's still easier, I think this portion of it is easier than the previous. But you're still going to have to use your equations from last time. It's just you get a nice graph too. So now we're going to be looking at velocity time graphs. Velocity time graphs are also called speed time graphs. So a speed time graph looks more like looks much like a distance time graph, but be sure you read the label. You have to actually make sure that we're dealing with a speed. So I will give you all random graphs and ask you questions on it. Make sure that you look and see what type of graph it is. So this is a speed time graph or velocity time graph. Speed is going to be on the side, time is always on the bottom. A straight line means that you are traveling at a constant speed. It is not changing over time. Whereas on a speed time graph, acceleration looks like a straight line. So this means that you are speeding up. And if you're slowing down, it would be sloped downward on a speed time graph. And again, this means constant speed, not changing. So this one you can be moving constantly at 55 miles an hour. This one you can start at 0 miles per hour and increase until like 100. This would be an example of you slamming on the brakes. So when comparing two objects, both of these people are increasing their speed. So both the dashed and solid line show increasing speed. Both lines reach the same top speed, but the solid one takes longer. So the solid line would be like someone easing on the gas pedal. The dashed line is someone slamming and pressing really hard on the gas pedal. So a speed time graph shows how much the speed of a moving object changes with time. The steeper the graph, the greater the acceleration. A horizontal line means that the object is moving at a constant speed. A downward sloping line means that they're slowing down. So when reading a speed time graph, this portion, a straight line, means that they're gaining speed. Here, so they're going from like 0, for example, they can be going from 0 miles per hour to 50 miles per hour. And they turn on cruise control and keep it 50 miles per hour. They get to a slow car, and they hit the gas a little bit, so they increase their speed up to like 60 miles per hour to pass around them. And then when they pass around them, they see a cop, and they hit on the brakes, and then the cop pulls out in front of them, and they have to come to a stop and pull over. So here they stop, they're slowing down, hitting the brakes, and they come to a stop. So make sure that you understand the difference. This is telling us. Here, this is telling us our speed values. So let's do some examples here. The speed time graphs below represent the motion of the car. Match the descriptions. So let's do it this way. So graph E matches which description? So E is constantly increasing. 7 is constantly increasing speed, so it's acceleration. So this would be 7. And we know this because it's a constant line. F is doing what? So we're slowing down. Because it's a negatively sloped line. G matches what? So there is no, well, this is flat. So this would be number 6. Because it's flat or horizontal. And the last one is 5. Because speed is 0. So this is 0. So remember, y'all all seen coordinates. So this bottom line represents 0. So if it's on the time axis, it means it has no speed. This one indicates that it has positive speed, that it's actually moving. So this also a straight line tells you the speed isn't changing, constant speed. So this has a constant speed of 0. So look at the graphs above. It shows how 3 runners ran a 100-meter race. Which runner won the race? So again, first thing you need to do when looking at this problem is make sure you see what graph this is. This is a distance graph. So who won the race? Albert. He ran it in 12 seconds. So he went from 0 meters to 100 meters in 12 seconds. So he ran 100 meters in 12 seconds. Everyone else took more time. Bob did it in 14 seconds. Charlie did it in 17 seconds. Which runner stopped? So he stopped at 50 meters. So Charlie stopped at 50 meters. And how long? This is 8 seconds. So he stopped at 8 seconds. And he began running at 13. So it was 5 seconds. How long did it take Bob to complete the race? Which one did I skip? Yeah. So Bob finished the race right here. He reached 100 meters right here, and he did it in 14 seconds. What is Albert's average speed? So remember that average speed is equal to total distance divided by total time. So his total distance is 100. So we're looking at the final spot. So we look from 0. So he went from 0 to 100. So the total distance is 100 meters. And now we look at time. He went from 0 seconds to 12 seconds. So his total time was 12 seconds. So his average speed was 8.333 meters per second. Did he run at a constant speed? He was constantly getting faster and faster. So he was light jogging at the beginning, and then he probably noticed Bob catching up to him, so he started running faster and faster until he reached the finish line. I think Usain Bolt, his top speed is what, 18 miles per hour? Yeah. So his top speed in meters per second, this is to give you an idea, he's the fastest man alive. He runs at 27.44 miles per hour is his top speed, sprinting speed, which equates to 12.27 meters per second. So 12 meters per second is like up there, top speed a human can go. Which means, if you see a person running 30 meters per second, you should probably realize your answer might be wrong. But then again, I changed y'all's numbers and it might not make sense. But you should at least go back and look at it if you get an answer like that. So, the graph below shows the speed of bus changes during a part of a journey. So again, we need the first look. This is a speed time graph. First thing you always do is look and see what graph we're dealing with. So the bus is what during segment 0 to A? So it's accelerating. Because this is a speed graph, straight lines mean acceleration. The bus is moving at what? So he's moving at a constant speed. Because this is flat right here, it would be constant speed. And we can tell it's 10 by reading this number right here. Constant speed of 10 meters per second. We know our units are meters per second because it's written right here. So the bus is blank between B and C. So that would be decelerating. It is going from 10 to 0 meters per second in 3 seconds. So we can see that it's right here to right here, so 3 seconds. The bus is what from between C and D? At rest. At rest means your speed is 0. So your speed is 0 between C and D. For line segment DE, so between D and E, it's accelerating. And what's it doing between E and F? And what's that constant speed? What speed is it? 5. That makes sense. Let me do one example. So looking at this paper, what is the acceleration between 0 and A? What is the acceleration of this line? So what's our equation for acceleration? Final minus initial over time. So what is our final? We look at the right input. So that'd be 10 meters per second. Alright, 10 meters. Our initial was 0. Or time is what? 5 seconds. So our acceleration, 10 minus 0 is 10. 10 divided by 5 is 2 meters per second squared. So we take these units, divide them by that units, meters per second squared. And you'll also have similar questions relating to the distance time graph. So distance, we've already worked. Remember that speed is equal to distance over time. So you'll be looking at the distance, you compare inputs, and plug them in. Does that make sense? Seem easier? Pass out that, please. Alright, I'm passing out homework. And that'll be it for the day.